Good evening, children.
Good evening. Good evening, ma'am.
Good evening. Hi, Bhavishya. Hi, Swati. Hi, Nandana. How are you all?
Fine, ma'am.
Good. I think Swati's video is lagging. All right. All the three of you have completed the assignment which I had sent on squares and square roots. And you've also completed the assignment based on the videos I had sent. Very good. So let's now discuss the answers. We'll see the answers to the assignment. Oh, I've already shared my screen, is it? Let me unshare. I'll ask you to give out the answers. Yeah, you cannot see my screen, right, children?
No, ma'am, it's not visible.
It's not visible. Yeah, we'll discuss the answers. I want the answers from you all. So we'll see the answers and then I'll share my screen. Yes, the first question. So the heading is find the square root of the numbers by prime factorization method and long division method, correct?
Yes, ma'am. Yes, ma'am.
Yeah. All right. What was the first number? 4,356, right?
Yeah, ma'am. Yes,
okay. Yes. So how do you express 4,356 as a product of its prime factors? What is the first step? 4,356 is equal to
3 power 2 into 2 power 2 into 11 power 2.
okay. Was that from Bhavishya? Who answered that?
Mama, Bhavishya, ma'am.
Very good. Yes. So 4,356 is equal to 2 square into 3 square into 11 square. We'll see all the steps. Now the final answer. Bhavishya, what is the square root of 4,356?
Ma'am, 66, ma'am.
66. Children, we'll see the answer with the steps. Now we'll just discuss the final answers and then I'll show you the steps for both the prime factorization method and the long division method. Okay. So the first one, Bhavishya is right. 4,356 is equal to 2 squared into 3 squared into 11 squared. And the square root of 4,356 is 66. Now, Swati, the second one, the second number is 2,304. Express
Yes,
2,000. Yeah, express 2,304 as a product of its prime factors.
Yes, ma'am. 2 raised to the power 2 into 2 squared into 2 squared into 2 squared into 3 squared, ma'am.
Very good, very good, very good. And what is the square root of 2,304?
It's 48, ma'am.
Very good, 48. Very good. Next number, Nandana, 39,204.
Ma'am, 2 power 2 into 3 power 2 into 3 power 2 into 11 power 2, ma'am.
Very good. And what is the square root of 39,204?
And it is 198.
Super. Very good. Yes, Bhavishya again. The number is 35,721.
For the 35,721, 7 power 2 into 3 power 2 into 3 power 2 into 3 power 2, ma'am.
Very good.
Is 189.
And the square root of 35,721 is 189. Very good. Yeah, Swati, what's your next number?
Ma'am, 50,625, ma'am.
Yes, yes, Swati. Express
Ma'am,
50,625 as a product of its prime factors.
Yes, ma'am. I did this using long division method, ma'am.
All right, darling.
Yes,
no,
ma'am.
but we have to do it in both the methods, right?
Yes, ma'am.
Yeah. Oh,
Ma'am,
you
but
forgot
I
to do
chose.
it? You forgot to do it in the prime. Okay, no problem. Let me ask you the next question. I'll ask Nandana this one.
Yes, ma'am.
Yes, Nandana.
Ma'am, it is 3 power 2 into 3 power 2 into 5 power 2 into 5 power 2, ma'am.
Very good. And the
And
square root
the
of
square root is
50,625 is
225, ma'am.
225. Very good. Very good. Swati, can you do the next one?
Actually, I have done the G1 using the prime factorization, ma'am. Other than that, I did using the long division, ma'am, because it's easier for me.
It's easier, that's right, darling. But the heading is to find, the instruction is to find the square root by both the methods.
I thought we can use either the methods, ma'am. So I did the 4 using prime factorization and another 4 using long division, ma'am.
No, the heading is find the square root of the following by prime factorization method and long division method, not or. Okay, that's okay. You can complete it later. Okay, then let me ask only Bhavashya and who else is there? Nandana. Okay. Why Harshita and others have not joined? I don't know. Ritika. All right. Where did we stop? We finished 50,625, right?
Yes, ma'am.
Okay, the next number is 25,921. 25,921. Whom should I ask? I think Nandana. Yes, Nandana. Express 25,921 as a product of its prime factors.
Ma'am, it is 7 power 2 into 23 power 2, ma'am.
Very good. 7 square into 23 square.
And the answer is 161, ma'am.
Okay. Instead of saying the answer, you must say, and the square root of 25,921 is 161.
Okay.
The square root of 25,921 is 161. Okay, very good.
Ma'am, shall I say for G?
Ma'am?
Yes, please.
Ma'am, yes, ma'am. For G, I got 41 squared, ma'am. And the
Yeah.
square root of 1,681 is 41, ma'am.
It's 41. Very good. The square root of 1,681 is 41. Very good. Yes. Yes, Bhavishya, what's your next number?
Ma'am, 1,17,649, ma'am.
Yeah, yes, go ahead.
Ma'am, for that 7 power 2 into 7 power 2 into 7 power 2, for that the square root of 1,17,649 is 343, ma'am.
Very good. I'm so happy. Very good. Very good. All right. Yes, Nandana or Swati?
Second.
Oh, yes, Nandana.
Ma'am, the power is 3 power 2 into 7 power 2 into 11 power 2, ma'am. The square root of
53,361
53,361
is 231. Very good. Okay. Somebody's mic is enabled. Please check and disable your mic, children. Okay. Next one. So Bhavishya again.
Yes, ma'am. 1,30,321, 19 power 2 into 19 power 2, ma'am. The square roots of the 1,30,321 is 361.
Is 361. Very good. Very good. Yes, I've got the right answer for all the questions. So excited. I'm so happy. Yeah, let me now share my screen. Yeah. I'll show you all the answers from the beginning, children. Please check. This is the first one. Exactly the same steps as I had explained in the videos. There will be no deviation. Whatever was explained, whatever procedure was explained in the videos, the same steps you will see here. I don't confuse students by doing it in different ways. I'll give you sufficient time, children. Please check. Ask me your doubts if you have any. Why like this? Why not like that? All such questions I'm interested in answering.
Ma'am, for some sums, I haven't do that long division.
You have to do, ma. Then what you do, you just take a screenshot, you try it by yourself and check the answer.
Okay.
Don't try to copy it now because that's of no use. If you have not done by the long division method, what you should do is take a screenshot now and try it by yourself and then check the answer. And see, I always go by the order. I'll first see the number is 4,000. This is the working children. This is the working. So the number is 4,356. I'll not take 3. I'll start with 2. The order of the prime factors 2, 3, 5, 7, 11, 13, 17, 19. I'll go in this order only. I'll not suddenly take 11, meaning directly take 11. So I always follow the order in which the prime factor, the ascending order, you know. But you can do it in any order. You can do it in any order. You can take 11 itself here. You can take 11, then 11, and then you can use 2, 2, and then 3, 3. Whatever you do, you will get the same set of prime factors. Just because you start with 11, it doesn't mean that you will get some other set of prime factors. All of you will get this one maybe in a different order. See, I have written 2 square, 3 square, and 11 square. If you have used these prime factors in a different order, then yours will look like 4, 3, 5, 6 is equal to 3 square into 2 square into 11 square. The order will be different. The order may be different, but you will get the same primes. All right, so I always start with 2. If 2 is not possible, then 3. I always start with 2. If that's not possible, then 3. That's also meaning not possible, meaning if the given number is not divisible by 3, then I try 5. If it's not divisible by 5, then I try 7. If it's not divisible by 7, then I go with 11. Not divisible by 11, 13. Not divisible by 13, 17. Not divisible by 17, 19. Not divisible by 19, 23. Not divisible by 23, then 29. Not divisible by 29, then 31. Not divisible by 31, then 37. Not divisible by 37, then 41. Like this. Like this, you should keep using the prime factors. So for some numbers, we've written 41 straight away. For some numbers, we've written 41 straight away because it was not divisible by 2, not divisible by 3, not divisible by 5, not divisible by 7, 11, 30. It was not divisible by any of these prime numbers. So we had to take 41 straight away. It's not that it was divisible by 2, but by choice I took 41. No, you tried to divide by 2, it was not divisible. Then you tried to divide by 3, it was not possible. That number 1681. 1681, remember in your homework? 1681. Why did we write 41? Why did we write 41? Because it 1681 is not divisible by any of these prime numbers till 37. 1681 is not divisible by any of these prime numbers till 37. It's divisible only by 41, that is 1681. 1681 is a product of 41 and 41. It's not divisible by any of these prime numbers. So we tried 2, we tried 3, we tried 5, we tried 7. Then we had to come up to 37. 37 also 1681 was not divisible. So then we tried 41 and 41 was. 1681 is divisible by 41. Am I clear, children?
Yes, ma'am.
All right.
Ma'am, I have a doubt, ma'am.
Yes.
Ma'am, for long division method, if the given number is not ending with 0, can we continue it? Suppose the remainder is beyond 0.
Yeah, in the further videos, we have questions like that. Okay, in the further videos. Now, for now, in this video or in this lesson plan, I have asked you to find the square roots of perfect squares only. All the numbers given to you are perfect squares. If the number is not a perfect square, you will learn the method to find the square root of that number approximately up to 2 or 3 decimal places. I'll repeat. If the given number is a perfect square, then when you use the long division method, we will get 0 as the remainder. If the given number is a perfect square, when you use the long division method, you will get 0 as the remainder, and the number you see in the quotient is the square root of the given number. If the number given is not a perfect square and you use the long division method, it's not a perfect square. Okay, and you use the long division method to find its square root. So you will not get 0 as a remainder. In that case, you have to continue the division process, this special division process, and find the square root of that imperfect square. Such numbers are called imperfect. IMPE, perfect squares, imperfect squares. Perfect squares, imperfect squares. So if the number is an imperfect square, then upon using the long division, you will not get 0 as a remainder, and you will be finding the square root of such a number up to, say, some 2 decimal places or 3 decimal places that will be mentioned to you in the question. Have I answered your question, Swati?
Yes, ma'am.
Okay, thank you. So now all the numbers are perfect squares. So when you use a long division, the remainder will be 0. All right, children. So see, I told you I'll start with 2. This number is divisible by 2. Again, it's divisible by 2. Then after this, it's not divisible by 2. See, this number is not divisible by 2. So I leave 2. Then I try with 3. It's divisible by 3. Now this number is also divisible by 3. Then after that, I got 121. This 121 is not divisible by 3. It's not that why you didn't use 3 again, because it's not divisible by 3. Then I try 5. After 2 and 3, I will try 5 only. It's not divisible. 1 to 1 is not divisible by 5. Then I'll check with 7. It's not divisible by 7. Then I'll check with 11. Yeah, it is divisible by 11. Okay, so it's like that. So please check. So first step is to express the given number as a product of its prime factors. That's the first step. Writing the given number as a product. See, a product, multiplication as a product of its prime factors. That's the first step. Then taking square root on both the sides. Taking square root on both the sides. That's the next step. That is the second step. Taking square root on both the sides. So first step, second step. In the next step, write this as it is, because we are finding the square root of 4,356. So write that as it is. Here we have to get rid of the square root symbol. Here in the RHS, we have to eliminate or get rid of the square root symbol, for which out of 2 equal factors, we bring 1 out of the square root. From 2 equal factors, we bring 1 out of the square root. So from 2 2's, 1 2 comes here. You don't see the square root symbol here, because from 2 2's you brought 1 out. So that's how you get rid of the square root symbol. So from 2 to 2 square, that means 2 2's. 1 2 comes out. 1 3 comes out. 1 11 comes out of the square root. So now you should not put the square root symbol here. 2 square is 2, 3 square is 3, 11 square is 11. So we have now eliminated the square root symbol. Now the product 2 3's, here the square root will come as it is. Now the product of these 3 numbers is 66. So this is the working for the prime factorization method. This is the long division method. So how does this work? Write on the number like this. So 4 3 5 6. We need to pair the digits from behind. That is this in this direction. So 5, 6 makes one pair, 4, 3 makes another pair. Group the digits from behind in the reverse order like this, in this way. Group the digits in twos from behind. That is not forwards like this, from behind like this. Okay. So 4, sorry. So 4, 3, 5, 6. Now you'll have to use the square numbers. You cannot use the regular tables. You'll have to use the square numbers. 1 into 1 is 1. You need to get the number 43. You need to get the number 43 or a number just less than 43. You must try to find the square number. You must try to find the square number which is equal to 43 or just less than 43. So 1 into 1 is 1, 2 2s are 4, 3 3s are 9, 4 4s are 16, 5 5s are 25, 6 6 are 36, 7 7s are 49. No, this is more than 43. So 6 6 are 36. 36 is the square number closest to 43. 36 is the square number closest to 43. So how do we write this? 6 6 are 36. 6 6 are 36. And subtract as usual. Subtract. 7 is the remainder. Bring the next pair down. Bring the next pair down. Am I audible, children? Am I audible and clear?
Yes, ma'am, you're clear.
Yes, ma'am.
Yes, ma'am.
All right. Bring the next pair down. Now, again, you'll have to find. Okay. So after this, double the quotient. I don't know how I've explained the video. Either it is double the quotient, or you can add this, whatever you have in the quotient here, you can just add it here to this one, 6 plus 6 and get 12 here. Or it is simply double the quotient. Double the quotient. Whatever I told in the video, there are two ways of explaining this. In the video, I said double the quotient, is it?
Yes, ma'am, you told to double.
Yes,
Like,
ma'am.
multiply.
Okay, let's use that method only. Double the quotient. Double the quotient. So we have 6 here. Double it. That is, yeah.
Ma'am, you didn't put 6 plus 6 1. You put the 6 and do 6 into 2, ma'am.
Louder.
Ma'am, in the video you told that in the quotient we should multiply it into 2, ma'am. 6
Correct.
into
That's
2.
what. Yeah. Correct. This is also another method. Forget this.
Okay, ma'am.
You can also do this one. Okay. So 6 into 2, 12. Don't write it very close to the margin. Don't write it very close to the margin. Leave a space here. You have to place one digit here. Whatever digit you place here, you must place the same digit here. Whatever digit, see, double the quotient. After subtracting 43 minus 36, 7 is the remainder. Then the next pair comes down. The next pair comes down. 5, 6 is the next pair that comes down. That comes down. Double the quotient, 12. Don't write it close to the margin. Whatever digit you place here, you must place the same digit here. Now, supposing you write 1 here, you will write 1 here also, and it will be 121 into 1, which is 121. No, the number is 756. Okay, so 122 into 2. 122 into whatever digit you place here, you must place the same thing here. So 122 into 2 is 144. Is 144. This number is 756. 144 is very small. So then you should try 3. 123 into 3. Like that. 124. 124 into 4. 125 into 5. So go on like that. When you do 126 into 6, you will get this number 756 exactly. And the remainder is 0. So whatever you find here, 66. The square root of the number, the given number is 66. Did you all understand that clearly from the video?
Yes, ma'am, understood.
Yes, ma'am, understood.
All right, children. Now, all right, children. So now I'll just check the answer. Let me see if others have joined. Yeah, now I can see Mritika and Harshita. Just a second, children. Yeah, thank you, children. So I think we're done with the first one. See the second one. So as I was telling you, to find the prime factors of this number, I start with 2. And then this number is no longer divisible by 2. So then because 2 is not possible, then I try 3. It's divisible by 3. I go on dividing by 3. As long as the number I get is divisible by 3, I keep dividing by 3. Then at this point, this number is no longer divisible by 3, 121. This number is no longer divisible by 3. So then I try 5. Not possible. Then I try 7. 121 is not divisible by 7. Then I take 11. 11 11s are 11 ones. Yeah, please take your steps. I'll explain the long division method also. We're going to take up a small test after discussing the answers. All right, let me tell you the long division method now. So we need to group the digits into in pairs from behind. So 0, 4 makes a pair, 9, 2 makes a pair, 3 stands alone. Because the number has only 5 digits. The number has only 5 digits. So you cannot group it in twos completely. 0, 4 makes a pair, 9, 2 makes a pair, 3 stands alone. So now the square numbers, 1 ones are 1. 1 into 1 is 1. 2 into 2 is 4. But the number we have here is 3. So we have to say 1 ones are 1. Because if you say 2 twos are 4, it's more than 3. So 1 ones are 1. Now subtract 3 minus 1, 2. Bring the next pair down. 9, 2 comes down. Double the quotient. 1 into 2. Double the quotient. 1 into 2, 2. Write it here. Write it here along this one. Write it here, 2. Don't write it close to the margin. Now, whatever digit you're going to place here, you'll have to place the same digit here. And the product should be 292 or just less than 292. You may get 292. The product you get should be 292 or a number just less than 292 or not anything less than 292. And it should be 290. The product should be 292 or something just less than 292. So let me just start from the beginning. So it will be like 20. See, when you add 1 here, it becomes 21. If you add 1 here, you should add the same digit here, 1. If you add 1 here, you must add the same digit 1 here. So it will become 21 into 1 is 21. Oh, that's very small. So 22 into 2. If you write 2 here, you must place the same digit 2 here. And then the product is 22 into 2. That's 44. That's very small. Okay, then 23. Okay, so 23 into 3. 23 into 3. What is 23 into 3? 69. Oh, that's very small. So we have to go ahead. 24 into 4. 24 into 4. 24 into 4 is what? 16. 1 carry over. 96. Oh my, that's very small again. So that is also not working. So now when you see, you're getting very small numbers, so you will not keep doing. So let's come from behind now. Because the number is 292. I'm not getting close to the number. So now let me come from behind. I'll use 9. I'll use 9 or I'll use 8 like that. Okay, let me use 8. 28 into 8. 28 into 8. What is 28 into 8? 28 into 8 is 8 is at 64. 6 carry over. 8 is a 16. 16 and 6 is 22. 224. Yeah, somewhat close, but you should make sure that there is no number just less than this. So you have to try 29 into 9. 28 into 8 is 224. It's close to 292, but we have to try 9 also. We have to try 9. So 29 into 9 is 29 into 9. 9 nines are 81. 8 carry over. 9 twos are 18. 18 and 8 is 26. Oh, this is the maximum digit you can place. Nothing beyond 9. You cannot write 10 and 10. You can place only one digit, a single digit. That single digit can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can place only a single digit. You cannot place 10, 11, 12 and all that. So the highest digit you can place is 9. So there is nothing to check beyond this. So 29 into 9 is 261. Yeah, that will be the right number, right digit. Okay, so we are not going with 28 into 8. We are going with 29 to 9. So we place 9 here and 9 here. And 29 into 9 is 261. And we subtract. On subtracting, we get 31 as the remainder. Then bring the next pair down. Bring the next pair down. 04 is the next pair. Bring it down. See here, you can see it here. Bring the next pair down. Double the quotient. Double the quotient. Double the quotient. What's the quotient? 19. 19. Double it into 2. 38. 38. Don't write it close to the margin. Write it like this. Now, whatever digit you place here, you must place the same digit here. Whatever digit you place here, you must place the same digit here. And see, when they say find the square root, if it is simply find the square root, the number is a perfect square. That means you must get 0 as a remainder. And you know this is the last step because you don't have any more pairs to bring down. You don't have any more pairs to bring down. So you know that this is the last step in division. So you want to get this number 3104 exactly. You don't want a number less than, just less than this. You want 3104 exactly. Because this is the last step. Why this is the last step? Because after 04, you don't have any more pairs that can come down. So now the number 3104 ends with 4. When can you get a 4 here? Either it will be 2 2s are 4 or it will be 8 8s are 64. These are the only two cases where you can get a 4 in the units place. Since this you can use this method you can use only in the last step, not everywhere. Because this is the concluding step. This is the final step. You have to get 3104. You have to get 3104. That means here the units digit is 4. When can you get a 4? Either it is 2. If you place a 2 here, 2 2s are 4. Or you can place an 8 here, 8 here, 8 8 are 64. So 2 will be too small. 2 will be too small. Like if you write 2 here, 382 into 2, 382 into 2, 382 into 2, 2 to the 4, 2 8 is 16, 1 carry over, 3 to the 6 plus 1, 764. We're getting 764. So then don't try other numbers. Take 8 straight away because only 8 either will give you a 4 in the end, in the ones place. So straight away, if not 2, then it is 8 only. So since 2 was not sufficient, we used 8. So it is 388 into 8. See, 380, 38 you got, right? Now you place an 8 here and an 8 here. So 388 into 8 is exactly 3104, and you close the division with 0 remainder. And you close the division with 0 remainder. And the square root of the given number is 198. All right, children. Now I'll only show you the answers. Check. Please check, children. Okay, next one. Any questions, children?
No, ma'am.
No,
You can
ma'am.
see, I can't force you, but it'll be nice. But if you can go in this order, instead of randomly using the prime numbers, randomly starting with 11, 5, then 2, then 3, you can use this order 2, 3, 5, and then 7, 11, 13. You can follow that order. So everywhere I followed the order. So here also on the last step, if you see the last step, it ends with 1. It ends with 1. So it will be 361 into 1. 361 into 1 will give me 1 in the end. 361 into 1. 361 into 1 will give me 1 here. 361 into 1 is 361. Will give me 1 here. If it is not 1, then I have to use 9 because 9 nines are 81. 9 nines are 81. 9 nines are 81. Will give me 1 in the end. I have to use 9 only. For the last step, I'm saying, you cannot use that for this step. In the steps in between. Last step, I'm saying, because you have to get the same number. So either you can use 1, you'll get a 1 here, or 9 nines are 81. Now I'm going to go fast. So for the in the last step, the number is 2,225. 1 month of vacation, even I've forgotten to read the numbers. So this number is 2,225 and it ends with 5. For 5, there's only one option. It's only 5 5s are 25. There is no other option. If you want to get 5 in the ones place or in the units place, you have to write 5 here because only 5 5s are 25. There is no alternative. So I'll be sharing the next lesson plan with you. You'll have to watch the videos. I'll not ask you to write it by Wednesday. If you can finish it by Wednesday, fine. But I don't know the amount of work you will have from school. So I cannot, force you to complete by the next class. I'll be sharing the next lesson plan on squares and square roots. Watch the videos. If you can complete the contents of the videos in your classwork, complete it. Otherwise, at least understand them. And there'll be a test based on the contents of that video in the next class.
Okay, ma'am.
Yeah. Don't just write, don't trouble yourself. Watch the videos at least and understand the contents of the videos. That is enough for the next class. If you have time, please complete it in your tuition notebook.
Okay, ma'am.
Yeah. So see here this number. Why we didn't write 2? It's not divisible by 2. Why we didn't write 3? It's not divisible by 3. Why not 5? It's not divisible by 5. I tried to divide by 2. It's not divisible. I'm getting remainder. It's not divisible by 3. It's not divisible by 5. So I chose 7. And it is divisible by 7. Then after 7, I could divide it by 7 2 times. 7, once I got 3703. Again, when I divide this by 7, I got 529. Now 7, it's not divisible by 7. So then I thought, okay, let me try 11. It's not divisible by 11. Okay, then I thought 13. No, it's not divisible by 13. Okay, then I thought 17. It's not divisible by 17. So like that, we go up till 23. So you keep checking like that, and then you come up to 23 and you realize that it's divisible by 23. 23 times 23 ones. All right, next one. See here, this is a special number, directly 41. It's not divisible by any number, any of the prime numbers till 37. So directly 41 only. 41 41s are 41 ones are. Swati, you said you did only by the long division method. Are your answers correct, Swati? Your steps?
Yes, ma'am. Everything is correct, ma'am.
Very good. So this number, no other primes other than 7. So here, if you have to get a 9 in the ones place, it's 3 3s are 9 or 7 7s are 49. Either it will be, you should try, you will already have 68 here. You will already have 68 here. Whatever digit you place here, you will have to place the same digit here. So either it will be 68, besides 68, if you write a 3, then it will be 3 here also. So it will be 683 into 3, or 687 into 7. 687 into 7. Because 7 sevens are 49. You'll get a 9 here and then. Or 3 threes are 9. Mritika and Harshita, kindly turn on your videos. Both of you, please stay back after the class and let me know your status regarding the assignment which I had sent on squares and square roots. All right, I'm not going to ask you now during the class. Please stay back and let me know your status. Okay, ma'am. Yeah. Don't forget and leave. Mritika and Harshita, kindly stay back after the class. Yes, children. Done with this?
Yes, ma'am. Check.
So see this number. So you'd have tried 2, 3, 5, 7, got tired, 11, 13, got very tired, 17, and finally 19. So you should, you should not lose hope. You should always be hopeful when you're doing squares and square roots. After trying 2, 3, 5, 7, 9, you should not feel hopeless. Sorry, not 9, 11, 13, you should not feel hopeless. You should always, there is hope. Yes, go on, 17, 19, see, 19.
That's the reason why I chose long division, ma'am.
Correct. Yeah. Now, if supposing, yes, let me say this now at this point. So supposing you're asked to find the square root of this number and the method is not specified, then please use the long division method. If it is specific now for now as beginners, we have to practice both the methods and we have to realize that it can be like this. A situation can be like this also, where you have to come up to 19. This number is not divisible by any prime factor less than 19. So if the question is find the square root of 1,30,321, that's all. The method is not specified. You can use any method and you can choose a long division method because, as you say, you get it easily than the prime factorization method. Okay. When the number, so in simple words, when the number is very large, when the number is large, go with the long division method. And the other trick is, supposing you're not able to find the factors using the prime factorization method, you can in the rough column work the answer by long division method, get the answer and then do the prime factorization method. This is the end of the assignment. All right, children. So this is this test. Start working. I'll give you 20 minutes for this one. Yeah. I'll give you 20 minutes for this one. What's the status, class? Are we done with all the 10 sums?
No, ma'am. No, ma'am.
No?
No, ma'am.
Okay, 6. Completed 6. Okay, I'll just wait for the. Okay, another 3 minutes I'll give you. All right, time up, children. Yes, what's the answer for the first one? What's the value of 7? Yeah. 7.5 the whole squared. How do we read that? Find the value of 7.5 the whole squared.
7.5 into 7.5.
Yeah, it is 7.5 into 7.5. It is 7.5 into 7.5. What's the answer?
56.25.
Again?
56.25, ma'am.
56.25. Correct. 56.25. What's the answer for the next one? What's the value of the square root of 121 by 169? How do you read the symbol? The square root of. This one is read as the square root of.
11 by 30.
So find the value of the square root of 121 by 169. What's the answer?
11 by 13.
11 by 30.
11 by 13. So you should present your steps like this. 121 is 11 into 11 divided by 169 is 13 into 13. So from 2 11s, 1 11 out. From 2 13s, 1 13 out. So 11 by 13. The value of this one is 11 by 13. I have the answer slide. You don't have. You can make a note if you want. Otherwise, I'll show you the answer slides. You can take it from there. Or I can wait now because these are very simple. No, if you want, you can write down now if you have not finished it. find the square root of 10,404 using the prime factorization method. What is the square root?
102.
102. How many of you got 102?
Ma'am, myself, Swati, I got.
Swati got 102.
Ma'am,
Who else? Harshita also got 102. Very good. Harshita, can you tell us the prime factorization of the number 10,404?
Ma'am, first 10,404 is divisible by 2, ma'am, and then 5,202, ma'am. That is also I divided by 2, ma'am, and 2,601, ma'am. That is not divisible by 2, ma'am. So I divided it by 3.
Harshita, yeah, I'm happy with the way you're answering. Let me just write what you're saying. So 2,5,2,0,2, correct?
Yes, ma'am.
Next, 2.
Ma'am, 2,601, ma'am.
2,601. Next.
Ma'am, and then 867, ma'am.
You're dividing this one by 3, is it?
Ma'am, yes, ma'am. 3, ma'am.
3, because it's not divisible by 2. So what is the quotient you get?
Ma'am, 867, ma'am. That is not divisible by any other number. So I divided it by 17, ma'am.
No, if you get 3 ones, you okay. What is the test of divisibility for 3?
Ma'am, sorry, ma'am, I didn't get it.
Okay. When we were in, so grade 5 or 6, we have learned the test of divisibility. How to check if a particular number is divisible by 3 without actually dividing by 3. Without dividing by 3, you have a procedure to check if the number is divisible by 3. What is that? Who can say?
Shall I
it can be a very large number. Without dividing by 3, you have a test to check if it is divisible by 3. What is that?
Ma'am, shall I say? Ma'am, it's
Yes.
sum of the digits, ma'am.
Okay, any other answer?
Ma'am, if the sum of the digits are divisible by 3, then the particular number is divisible by 3, ma'am.
Okay, Swati says that. I don't know. How many of you agree with Swati? She's right or wrong?
She's right, ma'am.
She's right. What about Bhavishya? Can you recall that?
Ma'am, for that I haven't do the sum, ma'am. Half only I done.
That's why I give such numbers. Very good. So let's learn from this. What is 8 plus 6?
14, ma'am.
What is it? 14. What is 14 plus 7?
21, ma'am.
30, ma'am.
Is 21 divisible by 3?
No, ma'am.
Yes,
Yes,
ma'am.
Yes, ma'am.
Then 867 is divisible by 3.
Yes, ma'am.
If the sum of the digits of the number, if the sum, that is only for 3. Don't apply this for all the numbers. This is the test of divisibility only for 3. Only for 3. For 2 it is different. For 5 it is different. For 7, 11, all that is different. Now for 3 we are talking only about 3. 8 plus, the number is 867. 8 plus 6, 14. 14 plus 7, 21. Is 21 divisible by 3? Yes. Then 867 is also divisible by 3. Got it, Harshita?
Yes, ma'am.
Yes. Class now. So Harshita, tell me 3 how many times? 3?
Ma'am, and then, ma'am, for me, I did it by 17, ma'am. So I don't know.
You leave your method. You leave your method. You would have got it correctly. You tell me. You continue by 3 now. 3?
Ma'am, and then, ma'am, I know, ma'am, for that 867, I divided it by 17, ma'am.
Okay, darling. Now you tell me what you will get if you divide by 3. Look at the screen and tell me. 3 2s are 6. Okay, you're not getting my question. Now divide by 3 and tell me, Harshita, what will you get?
Ma'am, like right now, ma'am.
Now tell me. Hmm. 3 2s are 6.
Ma'am, yes, ma'am. Ma'am, 3 2s are 6, ma'am. So we have 2, ma'am, left. So we bring down 6, ma'am. So it's 26, ma'am. Ma'am, 26 that doesn't come, ma'am. So we add 7 at the top, ma'am, and it is 21, ma'am. So we have remainder of 5, ma'am, and then we bring down 7, ma'am.
No, 3 8s are 24. 3 8s are 24, 2 is a remainder, 3 9s are 27. Now it will be 17 times 17 ones are. Now you tell me what you have done. Now you read from your book.
Ma'am, I have divided it by 17, ma'am, and then it came for me 51, ma'am. So I divided 51 by 3, ma'am, and then I got 17, ma'am, and then I again divided it by 17, ma'am, and I got 1, ma'am.
Yeah, so in all you have also got 2 2s, 2 3s and 2 17s, correct?
Yes, ma'am.
Yeah, okay, that's what it is. So here you have divided by 17, and what did you get?
Ma'am, I got 51, ma'am.
51. 51.
Yes, ma'am.
Okay, 51, right. Then you again divide by 17, is it?
Yes, ma'am.
No, 3.
No, ma'am. Yes, ma'am. 3, ma'am. 3, ma'am.
And you got 17. And
Yes,
then
ma'am.
71. So again, you're also getting 2 2s, 2 3s, and 2 17s. Here also we are getting 2 2s, 2 3s, and 2 17s. Okay, fine. You're right, Harshita. So the square root of 10404 is what, children? 102.
102.
102, ma'am.
Yeah.
And can I take the answer for it?
Okay. And then now what's the answer for the fourth one?
And the square root of 23,61,000. 6,196 is 486.
486. Is that correct? Class? Is 486 the correct answer?
Yes, ma'am, I got the same one, 486.
Okay, Swati's got 486. Harshita, were you able to do it?
Ma'am, no, ma'am. I didn't actually complete it, ma'am. I was half the way through, ma'am.
Okay, Bhavishya?
Ma'am, last step I'm doing, ma'am.
Okay.
Ma'am, shall I say how I did using long division?
Yes.
Yes, ma'am. Ma'am, first I just add up from starting from the ones place, ma'am.
Okay.
So the first one that I solved was 23, ma'am. The number that just less than 23 is 16, ma'am.
Yeah.
So 16 comes when it is multiplied like 4 into 4, ma'am. And then after subtracting it, we will be getting 7, ma'am.
Okay.
So we need to just put down the next pair, ma'am, that is 61.
Bring the next pair down. Yeah.
Yes, ma'am. And after bringing it, we need to double the quotient, ma'am.
Double
So
the
after
quotient.
doubling it, we will be getting 8, ma'am.
Yeah.
And we need to multiply it until we get a number that is just less than 761, ma'am.
Yeah.
So by multiplying 88 into 8, we'll be getting 704, ma'am.
Okay.
So that is just less than 761. And then after subtracting it, we will be getting 57, ma'am.
Okay.
And then we need to bring the next pair, ma'am, that is 96.
Okay.
And after that, we need to double the quotient, ma'am. So
Yeah.
48 into 2, that will give you 96, ma'am.
Correct.
So while looking at the last digit, 6 will be there, ma'am. So we will get 6 when we multiply it with 4 or 6, ma'am.
Yeah.
So 966 into 6 will give you the exact number 5796.
966 into 6 will give us exactly 5796. Very good.
Yes,
Perfect.
ma'am.
Yeah, perfect. Okay. Okay, class, I'll do one thing. I want all of you to try All of you have not completed, right, till the 10th one?
Ma'am, I completed until the 8th one. Ma'am.
8. Okay, that's because I want all of you. I don't want to give out the answers. Now we have discussed till we'll just discuss till the 5th one. The remaining you completed, we'll see the answers in the next class.
Yes, ma'am.
Yeah. Now Nandana has answered, Swati's answered. Harshit also tried one. Bhavishya, what's the answer for the 5th one?
Ma'am, 11, ma'am. Minus 11.
Bhavishya, it's 11, huh?
Yes, ma'am.
Okay. Any other? How many of you agree with Bhavishya's answer 11?
Ma'am, I got -1, ma'am.
You got -1. Nandana also got -1. Okay, and what about Harshita? Bhavishya, what is the value of root 25? What is the square root of 25? What is the square root of 25, Bhavishya?
150, ma'am.
Okay, so there are children still thinking about this. So let me not say because I want you all to get it.
Ma'am, the answer is -1, ma'am.
Harshita, is it?
Yes, ma'am. Ma'am, can I explain?
Yeah, please tell me. Tell me, Harshita.
Ma'am, shall I?
What happened to Harshita? She's not there. She wanted to try it.
Ma'am, shall I say it?
Now let me ask Bhavishya again. Bhavishya, can you correct yourself?
Ma'am, I'm solving that, ma'am.
No, Bhavishya, my question is what is the square root of 25? Okay. Swati or Nandana, what is the square root of 25?
5, ma'am.
5. Bhavishya, 5 minus, what is the square root of 36?
6, ma'am.
6. What is 5 minus 6?
-1, ma'am.
Minus 1. We cannot subtract. You cannot do root 25 minus root 36. You cannot, this is not equal to square root of 25 minus 36. It's not equal to this. Whenever it is addition or subtraction, if it's multiplication, you can multiply. Now, for example, if it was square root of 25 into square root of 36, then you can write it as square root of 25 into 36. If it is square root of 25 divided by square root of 36, you can write it as square root of 25 by 36 like this. But addition and subtraction, you cannot combine. That is, if in multiplication and division, they are under different square roots. If they are under different square roots, you can put them under the same square root and multiply. And you can put them under the same square root and divide 25 by 36 under the same square root and divide like this. But for addition and subtraction, you cannot do that. If it's addition, subtraction, root 25 minus root 36, it is not equal to root of 25 minus 36. When it's addition, subtraction, you cannot put them under the same square root like this. You cannot do this. So you should find this value, 5. You must find this value, 6. 5 minus 6, which is minus 1. Answers from 6 to 10, we'll see in the next class. Now I'll just, sorry.
Ma'am, I have a doubt in the 9th question.
No, not now, darling, because I want all of them to try. Okay, so please, we have to hold till the next class. Yeah. Yes, children, have I shared my, yeah, my screen is shared, right? Yeah, it is. Okay.
Yes, ma'am.
Yeah, you can check the answer for the first one. You can take a screenshot, or this is the answer for the first one. Second one. Third one.
Yes, ma'am.
Yeah.
Done, ma'am.
All right. Fifth one. Please complete the rest of the answers. If you have not completed, we'll see the answers in the next class. And I'll also be sharing the next lesson plan on squares and square roots. Please watch the videos. As I told you earlier, it's okay if you cannot complete it in your notebook, but you should have watched it to be ready for the next class.
Can you show me the questions that is from 6 to 10?
10 questions, is it? Here.
Yes. Yeah, ma'am. Thank you.
All right. All right, children. So that's it for today's session. Thank you so much. Good night. Harshita.
Thank you, ma'am.
Yeah, thank you,
Ma'am.
children. Thank you, Nandana. Thank you,
Thank you,
Bhavishya.
ma'am.
Swati, good night. Harshita, please wait. I'll just stop my recording and then we'll discuss.
Yes, ma'am.